and I'm going to talk about how to improve your observability game. We are running a little bit behind on time, so I'm going to try and speed things up because I can see a lot of you are very hungry. So what I'm going to talk about specifically is help you answer 3 key questions. What does an observability maturity roadmap look like, right? And how do you progress in your capabilities? And what holds us back from maturing that particular practice and the things we want to get to? And how do we address the gap? Because ultimately, we want to go from good observability to great observability, and we want to maximize our investment with New Relic. So let me talk a little bit about observability maturity. There's good news and bad news. The bad news is there's no industry blueprint for how to mature your observability practice, right? As vendors, we haven't come together and defined the blueprint. The good news is New Relic has been developing a blueprint for the last 3 years. Some of you may be familiar with it. It's called Observability Maturity Architecture. Anyone familiar with that? Okay, not many. That's all right. So what I have here on the screen is the simplified version of that maturity model. And what we find is customers go through 3 stages of observability maturity. If we start at the bottom, it's the reactive observability. And in this stage, your primary focus is on uptime, performance, and reliability, right? Which is a key cornerstone for any observability practice. If you're in this stage, you're using New Relic to understand your systems, to solve unexpected problems, to measure the impact of change, and to maintain the reliability, the general reliability and health of your environment, right? Think about that. Many of you, I think, will be in this stage of observability today. Once customers master the reactive stage, they move to they graduate to the next stage, which is proactive. And this is an additive stage, right? It's not either or, it's additive. And here, the focus actually shifts to optimization. It's no longer about reacting and fixing problems. It's about looking at the data and optimizing, getting more value out of that data. So for example, you might be optimizing software with APM. How would you do that today with APM? You would look at the critical path. You identify the critical path and you optimize the bottlenecks in that critical path. Number 2 is optimizing resources. Many of us have very large cloud bills and we're all being asked to reduce them. It's not actually that complicated to optimizing resources with New Relic using infrastructure monitoring. The 3rd is improving business metrics, right? So observability, as we heard today, is not just about performance, bits and bytes, it's also about business KPIs. We can improve things like conversion rates, we can measure those, we can improve bounce rates. Then the 4th there is obviously the end user experience. Browser and mobile, we want to make sure they're getting a good core Web Vital experience, and we can do that with our integrations. And then one of the up-and-coming use cases is actually optimizing the software delivery process. Because if you think about today with agile software development, there's huge amounts of infrastructure required to test every merge, right, and every commit. And you can use things like distributed tracing to optimize those processes. So these are just some examples. And the reality is what I hear from most customers is this is where they want to be, but this is not where they are, right? So this is where they want to get to. And we'll talk about why this is the case shortly. And the last stage, in my opinion, is the holy grail, which is preventative, right? Preventative is really about predicting and anticipating problems before you or your customers experience them. And the only real way of achieving this is to actually identify leading indicators within your environment. Now, it sounds a lot easier than it really is. It's kind of like predicting the stock price, right? It's actually quite difficult. So don't be fooled if anyone tells you that they're actually achieving this. So in practice, most customers I talk to are nowhere near this stage, right? It's very much aspirational. Now here's where I'm going to throw a bit of a spanner in the works with this presentation, because look, proactive and preventative are where we should all aim for. But in practice, many organizations I talk to are still struggling with the reactive stage. And in particular, they're struggling with solving unexpected problems. And I want to emphasize the word unexpected here. We're not talking about solving problems you've seen before. That's easy. We're talking about solving problems you've never seen. And that's really the key difference between monitoring and observability. Can you actually solve unexpected problems? Because you don't know what the conditions are, right? So the conclusion I came to is to give you the most value out of this presentation is to talk to you about how to solve these unexpected problems, right? Let's talk about why this is so hard, right? Let's think about the complexity of modern-day software architectures. This picture illustrates the challenge I think many of you in this room will face today. On the left, we have one distributed trace for one New Relic customer. This particular trace touches 158 services, makes 557 calls, and completes in under 5 seconds. In addition to that complexity, this customer has to manage their software and their infrastructure across 4 cloud providers, 17,000 databases, 24,000 microservices, and they do 10,000 deploys a day. I have a question. Is anyone near this scale? Anyone? Close? Half? Half. Okay. 2. Awesome. This is not a typo. This is actually a real New Relic customer. They're the largest online marketplace in South America, called Mercado Libre. Public reference. So I'm not giving away any secrets. Now, actually, I need to go back one slide. No, I don't. Now, I realize that's an extreme example, right? There's probably only 2 of you that are getting anywhere near that scale. But if you think about it, we're all dealing with the same challenges at different scale, right? What are those challenges? We all operate in very highly distributed environments. We're all running microservices architectures. Otherwise, we couldn't scale at all. Customers are accessing our systems. Everyone's doing online now, 24/7. So there's never a good time for downtime. And systems are constantly changing underneath us without our knowledge, right? Lots of developers in the room. You're merging code all the time. Engineers don't even know that's happening. And the last one there is, if you think about investigating a problem, there's hundreds of dependencies now. So how do you actually wrap your arms around that to get to the root cause, right? So the realization I had when I put this presentation together was, and this is my quote, you can't really excel at observability if you haven't mastered problem solving in complex environments. I have a question. Who here feels like they're experts at problem solving? Is anyone brave enough to put their hand up? Doesn't look like it. Okay, I've got the right audience. So my goal now for the rest of the presentation is to help you master complex problem solving. I've been doing it for 25 years, so I'm going to impart some of my knowledge. All right, so this is going to be the recipe. There's 5 key ingredients to solve complex problems, and I'm talking about unexpected problems. Number 1, we need knowledge. We actually need to understand the different telemetry data types that New Relic collects, how they should be used, what questions you can answer with them, and what questions you can't answer with them. That's number 1. Number 2, we need diverse sources of data to look at a problem from different angles. If you look at lots of different graphs and telemetry data, you'll see a lot of coincidences. So how do we eliminate those coincidences? We need diverse data for that. Number 3, we need New Relic features to help us narrow down the problem quickly. Not just narrow down the problem, we also need to understand the impact radius as quickly as possible so we know who to bring in to solve that problem. Number 4, we need the benefit of experience. As I said, I've got 25 years experience. If you're just starting out, how do you acquire that experience, right? If you have the experience, then you can streamline the decision-making process. And lastly, we need a repeatable process that we can use for any type of problem. We want one process for any type of problem, not different processes for different problems. All right, so let's understand more deeply the different types of telemetry data and how we should use them, right? So everyone talked about metrics today. Metrics simply put are aggregate measurements of events over time intervals. And that should give you a hint of what they're good at and what they're not good at. Right? Metrics are good at describing populations. They're good at describing broad symptoms, but they're actually not good at describing narrow symptoms. Right? They're also good at trending. Right? In New Relic, we store metrics for 30 months. So you can trend anything, any type of measurement. And they're also ubiquitous, meaning most things will emit metrics. Right? Which is great, because we need different data points from different systems. Now, the questions we usually ask with metrics are things like this. Has a measurement changed recently? So really what we're looking for is deviations in that particular measurement. We're looking for changes, change points. We can also ask, how does a measurement compare to a previous period? So how did this measurement compare to yesterday, the last week, the last month? That will help us understand whether things are normal or abnormal, right? That's our baseline. And what direction is the measurement trending in? Are things slowing down? Are things speeding up? These are all useful questions we can ask with metrics. So the simple takeaway for metrics is they help us detect broad changes in behavior. Keep that in your mind. All right, now let's look at events. Events don't replace metrics, they complement metrics. Why is that? Because they're discrete. They capture a lot of additional detail about a particular request. For example, coupon codes. Customers use them, right? Details about the user or the user's preferences, things they like, things they dislike. You can capture all those things with events within New Relic. And questions we typically ask of events are things like what type of request was made and where. How long did the request take? Who made the request? These are all questions you can ask with events. One real key question you can ask with events within New Relic is what's changed. And this will become clear much later when I talk about deployment markers. So, you can ask a question. Did someone change a configuration? Did someone release new software? Was there an actual marketing campaign run, right? If your business runs a marketing campaign, you'll probably see an increase in throughput. If you don't understand that that campaign was run, you're probably going to think something's wrong. So it's important to capture these events. The downside to events is they're short-lived, right? We keep them within New Relic for 8 days because they consume a lot of storage. So we don't use them for things like trending, okay? And so the takeaway here is events help us characterize behavior at granular levels and narrow down the problem. And the key point there is granular, right? Metrics we said was broad. Events make things granular. The third telemetry data type is logs, and we talked about logs today. Logs are simply events within New Relic. There are some slight differences. One is they're semi-structured, meaning that you can store arbitrary information, whereas with an event, you need some kind of data model, right? And like metrics, logs are ubiquitous. So they're actually great for instrumenting your legacy systems, right? Most legacy systems will emit some kind of log. The problem with logs, though, is they're messy. You really don't know what to expect. Ultimately, it comes down to the developer. Did they log something useful or not, right? And if they don't have a data model to follow, then they're probably going to log things that are not useful. So that's the downside. But there is a major benefit to logs. You can ask questions like what happened before an event and what happened after an event. And you have that chronological order that you can look at. Assuming your developers are logging useful information, logs will help us answer why something is broken. That's the key use case for logs in a observability practice. The last data type is distributed traces, and these are simply just connected events within New Relic. What's really important about distributed traces is they help us establish the causal relationship between your services, right? That's actually really important Because metrics only tell us, you can use metrics to identify correlations, but that doesn't mean it's causal in nature. Whereas distributed traces, you can guarantee that this transaction took a particular path and touched these particular services. You're not guessing, right? So we can ask questions like, what path did a request take? Which steps within that path is taking longer than usual? We can also ask what errors were emitted during that transaction. And we can also ask questions like, are errors elevated for a particular transaction? The downside to traces, and not many people in the industry talk about downsides to traces, is that they're brittle. Meaning that in that last example that I showed you of that really big customer, they had, I think, 156 services for one transaction. They all have to be instrumented to get an end-to-end view of that transaction. And that's not always easy when you've got hundreds of different developer teams and you're asking them, please instrument your service, right? It's harder than it sounds. So if you can't instrument everything, traces actually, you end up with lots of dead ends. And you won't actually get the value that they're designed to deliver. All right, so that's the downside. But the takeaway is distributed traces help us track down the source of problems when the problem is not obvious. If you have a very simple environment, you probably won't need distributed traces. Right? You'll probably be able to live with metrics. But if you have a complex environment with complex interactions, you can't live without distributed traces in this day and age. It's mandatory. And I guarantee you, not all you in this room are using distributed traces, because I know the statistics. All right, so that's it for telemetry, right? The takeaway is all four data types are complementary, right? One is not a good substitute for another. I've heard some customers, they use logs and produce metrics from logs. I don't think that's a great idea, right? All of them are useful in answering different questions. So we also need diverse sources of data. And again, I want to emphasize the word here, diverse. So this is a typical application made up of 3 layers, and there are 3 diverse sources of data here. You've got the end user layer, which includes your mobile and browser applications. You've got your services layer, which implements your business logic, and the resources your applications consume. The end user layer is actually becoming a lot more important to instrument. And there's 2 reasons. One is devices are now very diverse, and you can't possibly test every combination in non-prod, right? It's just not possible. Second is, most applications these days make external calls to APIs that you simply don't control. So if you don't have visibility of that, you've got no idea whether your customers are having a good experience or a bad experience. You're just making an assumption that things are working, right? So it's very important to instrument this layer. And again, I guarantee you not all of you are doing it today. The services layer is obviously important. This is what most people think about first. Let's instrument the back end, right? And that's obviously critical because that's your software. That's the software you control. And so that must be instrumented. And the last one is the resources layer. It's important to instrument resources because ultimately they're finite. Everyone talked about auto-scaling. Auto-scaling doesn't scale forever, unfortunately. It still has limits, right? Even cloud providers have limits. Sometimes we try and auto-scale and we don't get the instance. So you want to understand that scenario, right? So again, important to monitor your resources as well. Now, the question I usually get asked by all customers is, do we need to instrument all these layers? And the simple answer is yes, right? What you see here is my leaky bucket analogy. The water is the root cause of your problem. What happens when you don't instrument all the layers? You end up with holes in the bucket. And the root cause leaks out, right? And we heard from some customers here, there's no manager that wants to hear that we couldn't identify the root cause and that the problem may happen again, right? That's not a conversation I would want to have with my manager. You need to be able to find the root cause so then you can put actions in place to prevent that from happening again. This fundamentally, in my view, is what stops you from progressing from the reactive stage to the proactive stage, right? So think about within your own environments whether you are actually instrumenting all the layers. Because if you're not, that root cause will leak out. And your observability capabilities will be questioned by your management, right? All right. We also need tools, capabilities from New Relic. I'm only going to talk about New Relic. Obviously, there's other solutions out there. And ultimately, these are designed to help you narrow down the source of problems as quickly as possible, because obviously time is money, right? You don't want to keep your customers waiting. So first capability I recommend within New Relic is what we call New Relic workloads. And these allow you to group entities. Entities within New Relic are just objects that you actually care about. So it might be the services and users that you care about and infrastructure for your particular business unit or particular big business process, okay? And once you do this, you can actually look at a workload to understand its overall health, also understand the health of individual components within that workload and which ones are blinking red, orange, green, right? And what you can do in real time is see the impact radius as a problem is happening in real time within your Relic. And really important is you can see the dependencies. So you see the map down the bottom, you can actually see the dependencies and how these different entities are dependent on each other, interacting, and what state each of them is in. The last thing that's really important, you can see a timeline of events on the right. For every entity within that workload. So if something has occurred for that particular entity, we will actually raise that within this view, right? So workloads are really useful at helping you understand the scope of the problem you're dealing with to improve your mean time to understanding. It's not going to tell you exactly where the problem is, but it's actually going to help you start to understand the problem much faster, okay? The second capability is distributed tracing. I love this quote from Kai-Su Lee. He's a Google SRE presented at SRECon in Americas this year. He said, you can find the needle in the haystack if you thread the needle through the stack with a propagation tag. And that is exactly what distributed tracing does. It gives you the ability to visualize and analyze complex transaction flows in your distributed system so you can narrow in on the problem really quickly. And in New Relic, we actually have some specific capabilities to help you quickly compare transactions, both the durations and errors between different time periods. And what that allows you to do is determine whether this transaction is actually slowed down or it's now emitting a lot more errors than usual. Most transactions in most customers emit errors, right? There's always a constant stream of errors. So really what you want to look at is the deviations within those errors that are being thrown. The next capability is deployment markers. How many of you are using deployment markers? I'm disappointed. Not enough. And here's the reason. This is the simplest, easiest thing you could do within your environment, and it's free. It literally won't cost you anything. Here's why you need to use them. They allow you to describe notable events in your environment. Now, the name's a bit of a misnomer. We call them deployment markers. We're actually going to change the name in the next couple of months and just call them markers. You can describe any event with these things. Infrastructure changes. If you change your AWS instance from large to M5, whatever, you want to capture that information because it's going to change the metrics, right? And what happens when you see deviations in metrics? You worry. You don't need to worry if you knew that event happened. Configuration changes. Customers use them for that. Software releases, very obvious. They should be used for every release. Also, feature flags. I guarantee many of you here are using feature flags. So if you go from 10 to 20 to 50%, they should be marked, right? Because they're going to change the metrics. and business events. Again, if someone runs a marketing campaign, we should understand that if we expect it to make a material change to the metrics and events and logs that we're looking at. And this is just an example. These charts are actually changing in the next, I would say, 2 months. But essentially, those vertical lines are the markers, right? You send us the event, and we will overlay it on top of the charts. And very soon, we're going to overlay all deployment markers on top of every chart within your Relic. The last capability I think is essential is applied intelligence, right? We all have big brains here, but unfortunately, still not big enough to solve all problems. So we need some help from some intelligent systems. Applied intelligence within New Relic uses statistics, it uses learning algorithms and alerts to narrow down the problem for you, and it will propose a probable cause, right? The big caveat with all intelligent features is not just New Relic, it's only as good as the data you feed it. So if all you feed it is back-end data, it's not really going to be able to tell you if there's a front-end problem, right? So you have to feed it diverse data so that you can actually analyze and help you pinpoint the problem. So keep that in mind. It's a prerequisite for applied intelligence, diverse data, right? Including things like deployment markers. And I think Anupam is going to do a session on this later in the day with a lot more detail. So that's it for key capabilities. Now, how can we really shortcut the problem-solving process? We need a dose of experience. How do we get a dose of experience? We can all work with our peers for 5 years, get that experience. What else can we do? Well, I'm going to show you. There's actually a whole bunch of research papers out there that talk about incidents. This particular paper is from Microsoft called What Bugs Cause Production Cloud Incidents. What they did is they analyzed production incidents in Microsoft across a set of Microsoft Azure services over a 6-month period. And what they did is they classified the root cause of those incidents through the postmortems, right? Because what they wanted to understand is, if I understand the distribution of root causes, I can use that in my decision-making process, right? So what they found is 31% of incidents were due to software faults. Errors, right? Either throwing exceptions or not handling exceptions, timeouts, and silent corruption. And the other 21% was due to data format bugs, right? So incompatibility being introduced with new versions of software, and then two APIs can no longer talk to each other, right? Or the data models being broken. Interestingly, what they also found is most software incidents were resolved through mitigation strategies. So they're not trying to find the root cause during the incident, they're just trying to find a way to mitigate it as quickly as possible, and then go back later and find the root cause. And in my view, this is the only way you're going to get down to like a 15-minute mean time to repair, right? Is you have to mitigate. Don't try and solve it right then and there, because you'll never get the 15-minute recovery. And they also found that most software incidents are resolved by simply rolling back software. And I can guarantee that within New Relic, because I see the incidents we have, that is absolutely true, right? The first thing we do, roll back. So if you can roll back, do it. All right. Another study here, this one's quite old, 2003, is why do internet services fail? What can be done about it? Again, no surprise. The leading cause of incidents, operator error, right? To service failure. So people making configuration changes and getting it wrong. At least half of the incidents in this particular paper. There's tons of these papers. I could go through this all day, right? But if you do those two things, you'll probably solve 50% of your problems. Changes, errors, okay? So let's recap. We now have a good understanding of the questions to ask with different telemetry data types, right? We now know we actually need all four. We have diverse sources of data to help us triangulate around the problem. We have New Relic capabilities to help us narrow in on the problem. And now we have the benefit of hindsight and experience to solve problems. Now, how do we put all this together? So I searched the internet for problem solving in complex environments, and you know what I found? Nothing. No one teaches this stuff anymore. I don't know why. It's very confusing. So, to prepare for this presentation, I had to put my own process together. So this is the process. It's a little bit of an eye chart, but I'm pretty confident if you follow this process, you will solve your problems. Right? On the left, we have the simple problem-solving process, and on the right, we have the data and sources we need to solve those problems. And what you'll notice is a lot of these boxes correspond to things within New Relic, within the New Relic UI, within the panes that you can click in, and the different data sources that we capture within New Relic. I'm really pleased to see everyone taking a photo of this. There is one caveat to this. I've left out the user layer. And the only reason is because I couldn't fit it in the screen. But you'll get the idea. All right, so let's go through this problem, this process. All problems start at the top with symptoms, right? And they come from various sources. You see there, you've got your user journeys. I hope that many of you are monitoring your critical user journeys, right? And you might hear about those problems through customer complaints and tickets. You should have visibility of those. You've also got the alerting pipeline. So within New Relic, we'll look for anomalies. We'll notify you of issues within the thresholds that you've set. You can also alert on your error budgets within our SLOs and your synthetic monitors, right? Those things that are monitoring your environment whilst you're sleeping, the robots. And the other symptom just may come from you as engineers looking at dashboards and looking at some deviations and thinking something's not right, right? So that's the symptoms. The first step to problem solving is to investigate the service those symptoms are highlighting. Now, this is where you need some intuition, right, to figure out which service to start investigating. What I generally recommend is pick the service that is furthest downstream to the symptom, because most problems just bubble up. So you want to kind of skip that step and go as deep as possible into the graph, okay? The next step is to look for, we talked about, any changes to that service and related services, right? And so this is where workloads and deployment markers help, because they will show you the timeline of events for any service related, for that particular service or any service related to that service. And if you see that the change coincides with the symptom, what do? We roll back. Awesome. 5-minute MTTR right there, done. All right, next step. If that checks out, if there are no changes, you look for elevated errors. You look for elevated errors in the service, because we know that's a common source of problems. And we want to rule them out as quickly as possible. If you do see errors, where do you go next? Logs. Beautiful. See there? Down the bottom, highlighted. Got that right. Thank you. The next, you want to rule out all remaining local dependencies for that particular service. And for example, here, what's a local dependency is the infrastructure and the network, right? So I would be looking at the metrics associated with that infrastructure that service is consuming and seeing, is it normal, abnormal? Compare it to last day, last week, last month, right? If it's not normal, you have a lead to follow. If it's normal, let's go to the next step. The next step is remote dependencies. Now you could argue, depending on your architecture, you might actually start with the remote first before you go to local. That's something you need to think about. And when I look at remote dependencies, what I usually start with is databases. right? Because there's persistent storage, and storage can be quite volatile, right? Particularly in cloud environments, if you're not using provisioned IOPS, you're going to see a lot of volatility in I/O, and that's going to impact your database response times and connections. If that checks out, I'll look at external services, right? Look at the external services that that particular service depends on. Look at the golden signals associated with those external calls. And the last step, if that checks out, then we have to narrow in and look at transactions and see if there's a particular set or type of transaction that is being affected, right, versus the whole population, right? And we can trace that transaction using distributed traces, right? And that will show us where it's slowing down or where it's throwing errors. When you actually open that trace within your Relic, we'll do anomaly detection right then and there. And we'll compare the methods, the time a method usually takes against the distribution. And we will highlight the ones that exceed 2 standard deviations for you automatically. So you don't have to go do the comparison yourself. If that checks out, then we go to the next suspicious service, right? The distributed trace will show you what the next suspicious service is, and then you just follow the arrow up and you repeat the entire process until you get to your root cause. And that's it for the process, right? Problem solving, as you saw here, in this modern day and age that we all operate in, is not easy. But I'm confident if you use that recipe and use those 5 ingredients, it will help you master problem solving. And that ultimately will help you move out of that reactive stage of observability and into that proactive stage where you can actually start optimizing rather than solving problems every day.